Good morning, good afternoon, good evening, everybody. My name is Kartik. I'm one of the co-founders of ETHGlobal, and I'm super excited to welcome all of you to this amazing summit for ETHOnline. Now, ETHOnline, if you're joining us at the tail end of this, is a whole month of hacking and talking about all the amazing things that are happening in the Web3 ecosystem. We have a massive hackathon going on here with just 2 more days to go to tell you all about the results from, and this is our biggest event ever. We have over 2,000 hackers from 96 different countries, spanning 20 different time zones, working on really amazing projects. And we're going to be showing all of you what came out of this whole event this Friday. But today, the next 3 hours, our focus is around sharing some insights into what's happening in the world of data availability. So the next few hours are about our Data Availability Summit. We have 5 incredible talks from amazing speakers, and we're going to be covering everything you need to know about what this whole ecosystem looks like, how you can think about modularity on blockchains, and some upcoming problems that we need to solve and how to solve them as we think about scaling and getting billions more people to use this infrastructure. I want to give a special shout out to Yaz and the Celestia team for making this whole summit happen in terms of recommending amazing speakers, coming up with the great content that we're going to see today, and to give you an overview of how the next few talks are going to look like. We're going to start off by inviting Mustafa to talk about what modular blockchains are and the open problems in this space. Then Nick is going to talk about how do we verify all this information and how you can think about and understand and get a better intuition for the problems at scale. And John Adler is going to be speaking to you about Blob Stream and how do we actually make streaming data availability for Ethereum possible. And then we're going to get into some practical applications. So we'll kind of learn about Avail and how that architecture helps you make more modular decisions. And last but not least will be our talk on Polygon CDK on how do you kind of put all these things together and make a chain of your own that can have a lot of these new properties that we desire. So enough talking from me. Let's get started. We're going to start bringing on these 5 amazing speakers. So we'll kick off with our very first talk of today. I want to invite Mustafa to talk about modular blockchains and the open problems in the space. Mustafa, welcome.
Hey, thank you. Yeah, so I want to give a quick introduction to modular blockchains. And there's 4 parts to my talk. I'm going to be talking about what modular blockchains are and their benefits, their progress in 2023, open problems, and the final destination of what we're trying to achieve with modular blockchains. So between 2008 and 2020, blockchains were basically fit into this sort of monolithic era where you had Bitcoin and Ethereum, which had a very similar architecture where effectively you had a virtual environment, you had an execution environment. For Bitcoin, it was Bitcoin script. For Ethereum, it was the Ethereum virtual machine and some consensus mechanism. And those 2 things were kind of coupled together. So all the nodes ran the execution environment and executed every single transaction on the chain. And this wasn't scalable. So in 2019, this idea of decoupling consensus and execution started taking hold. And the general idea was, well, what if we had one chain that was only responsible for consensus and data availability, but the execution was offloaded off chain? And that's basically how rollups work. Rollups, they post their blocks to Ethereum or some other consensus and data layer like Celestia, but the actual computation and the actual execution and verification of those transactions happens off-chain in the rollup chain itself. And the execution for those transactions is proven to the consensus layer using proving systems like fraud proofs or validity proofs. And that basically what you end up with that is a sort of a modular blockchain paradigm where instead of having the consensus layer and the execution layer kind of enshrined into each other, like Ethereum was when it first launched, you now have this modular blockchain ecosystem where the base layer is only responsible for consensus and data. And on top of that base layer, you have a wide variety of execution layers in the form of rollups. And those execution layers are modular because they can all kind of have different architectures and disadvantages and advantages, and they can use different programming languages. So, for example, you have non-EVM rollups. So your rollup doesn't even have to use the EVM. Like, for example, Slackware uses Cairo. And I'm going to decompose what the different layers are of the modular stack to discuss a little bit about the theory of modular blockchains. So, as I mentioned, first of all, you have the consensus layer. And what the consensus layer does in a nutshell is it basically takes in some arbitrary messages that a developer has provided, and it orders them. It provides some ordering over them so that people can agree which messages came first. Because you need to know which messages came first to know if the same coin is being spent twice, which transaction should be the valid one. And then on top of that, you have the data availability layer, which is once those messages are actually ordered, we need to prove to the world they've actually been published. Because it's all well and good ordering those messages, but if we haven't verified they've actually been published to the network, then no one can actually know what the state of the chain is, what the transactions are, and do things like prove fraud if there's an invalid transaction in it. And this is actually very similar to kind of like what the Bitcoin white paper proposed as the central component of Bitcoin that makes Bitcoin possible, was this idea of a timestamping server. Like this idea where you can just take a hash of block of items to be timestamped and widely publishing the hash. That's the main core aspect of a blockchain. And so Bitcoin was kind of like on the right track there, but Bitcoin itself enshrined the execution environment. But the core component is the timestamping server. So the core insight of modular blockchains is, what if we isolate that core component and allowed people to build their own execution environments on top of it? And if the base layer is only trying to be responsible for data availability and consensus, then it can specialize more in trying to scale data availability in ways that are more efficient than if it tried to do everything at once. And that includes using techniques like data availability sampling, where you can guarantee or you can check and verify that most of the block is available and has been published by only downloading a very small piece of that data. And so that's a very good way to scale blockchains, because now it's no longer the case that everyone has to download every single transaction and the entire data of the chain to verify it. And then on top of that, you have the execution layer, which uses the base layer below it, which provides consensus and data availability. And what the execution layer does is it takes in those arbitrary messages that have been ordered and published, and then does some kind of computation on top of it to output a state. And what that basically means is, if you assume those arbitrary messages are transactions, then it does some computation on those transactions, and then it outputs, for example, a table of accounts and balances. And that's basically the job of rollups in the kind of in a rollup centric ecosystem. They do this execution and they offload the data and the consensus to the base layer. And then optionally, you can also have a settlement layer, which is sort of like a special case of an execution layer that basically bridges other execution layers together. So if you have rollup A and a rollup B, and they can use some settlement layer by posting their proofs to it, and that settlement layer can allow liquidity to flow between those two rollups. And so kind of acting like as a bridging hub. So if we put all that together, what is a modular blockchain? We define a modular blockchain as basically a blockchain that fully outsources at least one of those components that we discussed. So let's go through what are some of the benefits of modularity and modular blockchains. So firstly, scalability. because rollups now have their own dedicated computation environment, which means that instead of having a single chain where everyone's transactions are executed, and that was kind of like the original Ethereum world computer model, where there was a single kind of world computer and everyone's transaction is executed on the same chain, on the same computer, and that doesn't scale, obviously. But with rollups, if you spin up a rollup, rollups have their own execution environments. So if a transaction happens on rollup A, then rollup B does not need to execute that transaction. And so that's very similar to sharding. It's effectively sharding execution and is inherently more scalable. The other thing is that if you use techniques like data availability sampling, you can create a system where the more light nodes you have, then the more block space you can have, while still keeping the chain verifiable and secure. Because with data availability sampling, light nodes can contribute to the verification of the chain. The other advantage is choice. So imagine if when you're building a website, you only had one choice of programming language. Like, what if every time you created a website, you had to use PHP or Python, and you can't use anything else? That's very similar to kind of the status quo with the Ethereum virtual machine. People with modular blockchains and with the ability for people to create rollups, people can now experiment with better or more customized execution environments. So, for example, you can have a parallelizable execution environment. You can have a execution environment that is more suited towards a specific purpose. For example, there's a project called Curio, which has modified the Ethereum virtual machine to make it more suitable for like real-time games or executing real-time games on it by embedding the actual game itself as a opcode to the EVM. And there's also different types of rollups that you can play around with, like sovereign rollups or normal rollups or Celestiums, which are sort of like rollups that use Ethereum rollups that use Celestia for DA, or Ethereum L2s, I should say. And so users now have a lot more choice in choosing what kind of components they want to use in their applications. And then you also have this idea of sovereign rollups. So there's a very big Cosmos ecosystem, but it's not viable for every time to create a new chain, you create a new validator set. So with sovereign rollups, it kind of gives you the best of both worlds because you can create your own sovereign chain without having your own validator set from scratch. So a quick overview of what the modular stack looks like today. It's a very widely growing stack. You have different projects in all different categories, including there's 4 categories I mentioned, but also things like sequencer services, rollup frameworks, even rollup as a service providers. You can just go on the website, upload your code, and immediately deploy your own rollup chain in seconds. And various kind of cross-chain bridging providers. And so who knows what the ecosystem will look like in a year's time. So let's go through some open problems in the modular blockchain ecosystem. The first one is kind of like we need better UX for bridging, because in a multi-rollup ecosystem, bridging kind of becomes more of a pain for users, especially if there's many different rollup and application-specific rollups as well. Then payment systems for resources across layers. So if a rollup has its own gas token, and it also needs the gas token for the layer, there kind of needs to be better billing for that to make it more seamless for people deploying rollups. There's also a lot of choices, so we need to make those choices easier to understand for developers. And maintaining the dependencies across the stack is also a challenge. And there's this idea of maybe we should define common interfaces. For example, a common DA interface for rollup frameworks instead of having a slightly different one for every framework. We also need to kind of like faster ZK proving systems and better developed fraud proving systems. I don't think there's any kind of completely deployed, decentralized fraud proving systems right now that's completely permissionless. And also privacy. This time you have an opportunity to actually try to enshrine privacy into the stack instead of just ignoring it. So what are some of the values of modular blockchains? First of all, light nodes. One of the biggest kind of disappointments of Web3 over the past decade is that everyone just uses centralized endpoints like Infura and Alchemy. But with light nodes, especially like using fraud proofs and sampling, we now have the opportunity to actually make it possible so that wallets connect directly to the peer-to-peer network instead of using some centralized RPC endpoint. We also have the opportunity to build a more positive sum ecosystem that's kind of like evolves past maximalism and have modularism where different components kind of interact with each other while they're trying to compete with each other. And finally, I think the most important reason is because we're basically kind of stuck in this endless cycle of new layer ones. So every cycle, every crypto cycle, there's this new layer ones. So like in 2014, we had EOS, Cardano, Tron. Then in the previous cycle, we had Solana, Avalanche, and in this cycle, we had Sui and Aptos and Definity, and they all promise to do something to have incremental improvement over the past cycle. But it's an endless cycle, and it's fundamentally extractive. So with the modular ecosystem, we can try to escape that cycle by having components that are reusable instead of having to deploy a whole new layer one ecosystem every time we want to make it incremental improvement. And so to summarize, and some of the values of summarize the values of modular blockchains. Firstly, users can be first-class citizens of the network by running light nodes. Secondly, we can escape maximalism and have a modular positive sum ecosystem. And thirdly, communities can choose to be sovereign if they want by having sovereign rollups, which give you the best of both worlds. So thank you. And if you want to learn more about modular blockchains, you can go on the Learn section on the celestia.org website.
Awesome. Well, thank you so much, Mustafa. I think we are running short on time, so we can't do a lot of Q&A, but that sets the stage for the rest of the chat, and really appreciate you sharing those insights. Amazing.
Sounds good. Thank you.
All right. So with that, we are ready for our second talk of the day. And for our second chat, I want to bring on Nick to talk about why verifiability is super important. We're going to hear about storing data differently, but what matters here is having a better answer to how do we actually ensure that decentralization is in place by getting to verify this by anybody and making sure that everything is consistent on the integrity of that information. So without further ado, let's welcome Nick to share all of his thoughts on verifiability. Hi.
Hey, Kartik. Thank you for having me.
Appreciate you being
here. Let me just my screen. All right. Can everyone see my screen?
Everything is great. I'll let you get started.
Perfect. Well, hello, everyone. The title of my talk today is Verifiable by All. And what I'm going to talk about specifically is why verifiability is at the core of what makes blockchains decentralized and secure, and specifically why a new node type called a light node that's enabled by modular blockchains makes blockchains for the first time verifiable by anyone. So it opens up accessibility and makes blockchains more decentralized and secure. So you may have seen, if you're on crypto Twitter in May, a bunch of memes that were circulating of people running light nodes, pieces of paper or in a club or on the COVID test. And people were having a lot of fun, memeing the Celestia light node. And I was really glad to see that everyone was embracing this idea of running a Celestia light node, but I wanted to make sure that the significance of light nodes was not lost amongst the humor of these memes. And so to understand why light nodes are so important to blockchains, and I would even say to sort of the future of humanity, we had to kind of zoom out a little bit and get high level. And I want to start by sharing a quote from Yuval Noah Harari, which is that humans have the unprecedented ability to cooperate flexibly in large numbers. And this is probably something that you don't think about very often, but one of the things that makes humans special among all the different animals is that we have the ability to work together in groups. And by cooperating and working together, we're able to do things that are much more powerful, and we're able to like create a better world for ourselves. And this is kind of a good way to understand this is by thinking about the difference between a single-celled organism like a bacterium and a multicellular organism like human beings themselves. And so like when in biology, when cells cooperate and work together, they're able to create organisms that are far more powerful and complex. And there's a similar thing happening, you know, at the human level. When human beings get together and cooperate, we're able to do things that are more powerful and complex. Now, in nature or in the wild, in a natural state, human beings are limited in the sort of the number of humans that can successfully cooperate together. And this is the so-called Dunbar number, and it's around 150. And fortunately, we've been able to transcend this sort of like built-in constraint of only being able to cooperate in a group size of 150. And this is one of the things that has actually led to our ability to sort of like expand and grow as a species and create more prosperity and well-being for everyone. And so one of the arcs of history is that, and I'm going to introduce this really important concept here, which is social scalability, which is the number of humans that can successfully cooperate in a given system. And one of the arcs of history has been that over time, human beings have been able to grow and increase social scalability by creating new technologies of cooperation. So, you know, in the ancient times, we cooperated at the scale of tribes. So maybe, you know, on the scale of hundreds of people or so. Then as time progressed, we started being able to cooperate at the scale of city-states, you know, maybe tens of thousands or hundreds of thousands of people. And now in modern times, we're able to cooperate at the scale of nation states, or, you know, on the scale of millions, tens of millions, sometimes hundreds or even billions of people. And we've gotten this far and created this like a world where we have more prosperity and we're able to do more powerful things like, you know, launch rockets up into space, because we have legacy sort of technology of cooperation. And the way that legacy cooperation systems work is that you start with a set of rules that everyone in the system agrees to follow. And you know, unfortunately, you can't stop there. You can't just trust that everyone in the system is going to follow the rules. So you have to empower another group of people, the rulers, who are meant to enforce those rules on everyone else. And this works pretty well. I mean, it's gotten us to where we are today, but unfortunately, it has a deep-seated problem within it. And that is that it's summed up in this question: who watches the watchman? So in other words, you know, who is enforcing the rules on the rulers? There's no one there to watch over their shoulders and make sure that they're actually, you know, following the rules themselves, or that they're not arbitrarily enforcing the rules on people that they favor for their own benefit. And unfortunately, they have an incentive to cheat, right? In a system of cooperation, if you can cheat, you can extract more value for yourself. And this is what corruption is. This is what fraud is. It's people who are breaking the rules for their own benefit. And we got a very good, you know, unfortunately had a sort of like recent example of this in what happened in FTX. And a lot of people, you know, took FTX and what happened as an example of what's wrong with crypto. But in fact, it's actually an example of what's wrong with our legacy systems of cooperation, because FTX is a legacy institution. And it's more of an example of why we need blockchains in the first place, because we need to decentralize and build something better than what we currently have, where our trust can be exploited. And so this is a really important concept, which is that trust in a system of cooperation, trust doesn't scale. When you have to trust someone or a group of people, then that becomes a sort of a security hole in the system. It becomes a place that the point of exploit, where someone can capture that point, then they can break the rules, right? And then they can sort of abuse the system of cooperation to their benefit. And that's why in the blockchain space, we're always using words like trustless or trust minimized. It's because what we're trying to do is build systems that are more socially scalable by removing trust. And that brings us to how blockchain cooperation systems work. And the way that blockchains work is very different to our legacy system, in that you have a set of rules, again, that everyone agrees to follow. And then rather than having a set of rulers that enforce the rules, it's actually the people, the users, the participants in the system who enforce the rules on each other. And this is really, really a totally different dynamic, because you no longer have this central party that is empowered, and everyone is on the same footing. Everyone is equally empowered and powerful in the system, so that there isn't a central point that can abuse its power on the rest of the system. So how does this work? It's almost, it sounds kind of too good to be true. Well, and I should also mention, this is not, it's really important that people realize that validators or miners in a blockchain system are not the ones enforcing the rules. And this is a really common misconception. It's actually, if it were the case, then we would just be kind of repeating the same patterns of legacy cooperation systems. Everyone would be trusting the validators to do the right thing, but no one would be there to actually enforce the rules on the validators. So that's not how blockchains work. And to explain like how blockchains do work under the hood, the way that users are actually able to enforce the rules themselves is by running a node of the network. So what a node is just a computer program that that knows what the rules of the chain are, and it constantly audits and verifies everything happening on chain to make sure that things are following the rules. If anyone tries to break the rules, then that block is ignored, and the fraud or whatever kind of malfeasance was trying to happen is stopped before it can even take place. So this is what enables the core value proposition of blockchains, which is they enable rules without rulers. So you can have a set of rules without having this privileged group to enforce them on other people. And this enables us to scale cooperation to the planet level scale, because you're replacing the need to trust individuals or groups of people with the need to just trust in cryptography. And that way you can actually connect everyone in the planet through a sort of a shared network of cryptographic trust. And this is the promise of blockchains, of what they can achieve and do for the world. But unfortunately, there's a problem, and that is that blockchains are not very technically scalable. So what I mean by technical scalability is the number of transactions that a blockchain can process per unit time. So blockchains inherently have a limit to the number of transactions that they can process. And that's because running a node is very inefficient. So if you're running a node in a monolithic system, like all the blockchains that currently exist today, you have to download all the data. You have to download every single transaction, and then you have to verify every single transaction that happens. And unfortunately, if you're a user, you may have a phone or a laptop or whatever like device you have has only a certain amount of bandwidth to download transactions, and only has a certain amount of computing power to verify these transactions. So at a certain point, you can't download more transactions and you can't verify more transactions. So this sets a limit to the amount of transactions that the overall network can process. And so that makes it so that you have this finite capacity of throughput of the system. And so this kind of like in many blockchains basically make a trade-off, which is that they say, okay, well, if not everyone can run a full node on their phone or their laptop, that's fine. They can run a light client, and we can increase the number of transactions that we process, that so-called scaling, but sacrifice actual social scalability by forcing people to run a light client rather than a full node, which is actually verifying the chain. And the problem with a light client is that it actually reintroduces trust in the system, because people who run a light client rather than a full node actually make a trust assumption on the validator set. So it kind of breaks the value proposition of blockchains in the first place. So you can see that there's kind of like this deep paradox or sort of dilemma, I would say, between social scalability and technical scalability. So on one side, you can have a blockchain that's very socially scalable because it limits the amount of throughput that it processes so that anyone can verify the chain. But then it's not very technically scalable because it can't process that many transactions. Or you can have a blockchain that's very technically scalable. It processes a ton of transactions, but it does that by increasing the cost for an end user to run a node, and therefore it prices a lot of people out from verifying the network and becomes less socially scalable. So this is sort of the dilemma of I would say of the monolithic blockchain era. And unfortunately, this means that we can't actually achieve the full potential for blockchain technology, and that neither of those systems actually scale to the planet. If you can only process 15 transactions per second or so, then not everyone in the planet can actually use this system. Or if you process a ton of transactions so that everyone can use it, then no one can verify it. So then, you're not actually building this cryptographic network of trust that anyone can use. And so this is really like the core problem of blockchain scalability. That is, it was until this guy, Mustafa Al-Bassam, who was just up here, published 2 white papers in 2018 and 19, where he described a new way of building blockchains, a new way of verifying blockchains, which is modular and uses some new technology that makes it significantly more technically and socially scalable. So the way that it works is that in a modular blockchain world, rather than downloading every single transaction and verifying every single transaction one by one, you simply download a tiny sample of the data, and then you can verify a single proof that all those transactions were executed correctly and that they're valid, and you can verify them. So what this means is that as the number of transactions that the system needs to process increases, the amount of work that you have to do to verify does not increase at the same rate. So this makes it so that we can actually have a system where we can process more and more transactions without pricing people out of being able to verify the network. And this enables this new node type that I was talking about, which is a light node. And a light node has achieves a similar level of social scalability of a full node with a similar level of technical sort of like scalability of a light client. So you don't have to make this trade-off anymore. You can actually have a system that achieves both of these properties at the same time. And you can see this represented in the node requirements of Celestia versus other blockchain nodes, and see that in many cases the requirements are an order of magnitude or more less than these other systems. And we believe, and I think this is a core value not just of Celestia but of the entire modular blockchain movement, that it's important that anyone anywhere should be able to run a node and verify the chain directly. And that's why we targeted the specs for running a light node to be compatible with running it on mobile devices, because mobile devices like smartphones are the most common and ubiquitous device in the world. It's an estimated like 5 billion people have a mobile device worldwide. And so if we can empower anyone in the world to run a light node on a phone, then all 5 billion people that own a phone could theoretically be connected in this cryptographic network of trust. And then we can actually scale this system, this blockchain cooperation system, to the planet. And it can be a system that everyone can use because it's technically scalable, and everyone can verify because it's socially scalable. And so we can actually, using modular blockchains, achieve this grand vision and state for what blockchains can enable. Now, this is really exciting, and obviously I'm very passionate about it. I think everyone in the Celestia team is very passionate about this vision, but the truth is there's still a lot of work to be done. So I made this slide as sort of like a depiction of all the different layers of the stack that need to come together and be built out in order to enable this vision to work at scale. We know that it's technically possible, and we have the first versions of lots of these things, but there's still a lot of work to be done to build them out to a level where it will actually work at that scale. And so this is sort of a message to all the protocol builders out there. If you're interested in this vision, there's tons of great work to be done, and this is a great time to get into the modular space while things are still so early, and there's so many great wins that we can have. A second part of this that needs to change in order to make this vision a reality is that we need to reduce the friction for people to run light nodes. So currently, the most common way to run a light node is using command line. And unfortunately, not that many people in the world actually know how to use command line. And so we need to make it into user-friendly applications that you can just download, make a couple of clicks, and be running a light node. And people like Josh on our team have built apps like Quasar, which I encourage everyone to check out, which makes this extremely simple to do. And I think in the future, light nodes will be embedded in people's crypto wallets and in the browser when they're using applications. And in that way, we will actually have these systems be verifiable by default, similar to how the privacy movement has a private by default. And last but not least, actually, we going back to the beginning of the talk, we need to make light nodes into a meme. We need to make them into a part of our culture that everyone actually runs a light node. It's kind of like a rite of passage. It's almost like, if you want to join this movement, the crypto movement, you have to run a light node, and that's kind of how you get baptized into what crypto is all about. And fortunately, the meme has been working, and a lot of people have been running light nodes in lots of different places in the world. On airplane Wi-Fi, the pyramids, or in a remote place in Vietnam. People have also been running light nodes on all different kinds of devices like Kindles or Nintendo Switches, and even someone ran one on their car. And so this is all great, but you might be wondering, why should I care? Why should I go through the effort of running a light node? I only have so much time in my day, and this just sounds like a lot of work, and like, does it really matter, right? And the answer is that you should care, because we're living in a world where people in power are our rights are increasingly being infringed upon by people in power. And we've seen a lot of examples of this recently, like recently in Canada, there were the Canadian government used the banking system as a way to suppress protests. So they kind of weaponized the financial system. We've also seen leaks about how there's censorship on social media, and there's widespread surveillance throughout the internet by governments. And I don't think it's a coincidence that trust in our institutions is at an all-time low, because I think people are waking up to the realization that the people in power don't always have your best interests at heart. And this may sound like a very sort of negative message, but the reality is we're really lucky, because in the past, our ancestors, when they had to stand up for their rights and what they believed in and what they deserved, they had to go to war. They had to fight. They had to put their lives on the line and fight against their oppressors, or whoever, fight against corruption. And the beautiful thing about blockchains is that they give us an alternative. They give us a non-violent path as a way for us to actually enforce our rights and claim back our sovereignty. And so rather than having to go to war, all we have to do is just run light nodes and use blockchains as a way to enforce our rights in a non-violent way. And I think that's really powerful. But even beyond that, light nodes are not just about fighting back, but they're also about taking the next step forward in the evolution of humanity, in that we can, using blockchains and light nodes, create the next scale of cooperation, and the next sort of build a more prosperous, democratic and peaceful society going forward. So I want everyone to, if you have a phone on you, just pick it up and realize that what you're holding in your hand is not, a phone or a camera or a computer. It's actually the key to your rights. It's the key to digital freedom, and it's also the key to a better future for humanity. So thank you very much. Hopefully you're inspired to run a light node and inspired to be part of the modular blockchain movement.
Nick, that was amazing. Definitely a really good case to make on why light nodes matter and how you can actually get started quickly. I think, as looking at the chat, people are already trying to figure out how to quickly get started on this. So this is awesome to see. And yeah, so I want to take a second to actually congratulate all of you on this amazing week. A lot of great updates from the Celestia team. So looks like the next few weeks and months are going to be even more exciting.
Thank you, Kartik. Yes, we have a big week coming up.
Awesome. Well, we want to get to the next talk. I want to make sure we respect everybody else's time as well from the speaker side. So next I want to bring on John to talk about Blobstream. This used to be, I believe, called the Gravity Bridge, last I remembered. And this is a way for you to stream a lot of data for Ethereum and make all of that modularity kind of come into practice with Ethereum chain. So without further ado, let's welcome John.
Hi, thanks for having me. Awesome, great. Can you guys hear me? He's gone. I'll assume you guys can hear me because I'm unmuted. Okay, here we go. So I'll talk about Blobstream today. As Kartik mentioned, this was formerly called actually Quantum Gravity Bridge, but that was a terrible name, so we renamed it to Blobstream recently. There's a blog post about this that's linked to later in the slides if you want to check it out. So now let me talk about what Blobstream is, its general architecture, what its benefits are over other data availability scaling solutions for Ethereum. So first, let's talk a little bit about Celestia to give a brief background of blobs, and then we'll talk about the streaming part of Blobstream. So what Celestia is the first modular blockchain network. It provides a highly scalable data availability layer that you can build execution layers on top of, or you can stream or relay attestations of data being available to other chains, such as Ethereum, which is what Blobstream will do. What is the benefit of being a data-only layer? Mustafa talked about this earlier in his talk, right? It means that you don't have the overhead of execution, settlement, all their stuff to deal with. You can just optimize and maximize for data availability. And therefore, for the same cost to run a node, you can have substantially higher data availability throughput than a traditional monolithic chain would have. And of course, the data availability is the most base thing. It's the basest of layers, and that's the thing that everything else can be built on top of. So the more capacity you have at the base layer for the same cost, the better it is, because you can always build more on top of it, but you can't really add more at the base layer without making sacrifices to decentralization, etc. Okay, so architecturally, and forgive the terrible diagrams, these were made by engineers, not artists. Celestia has these things called blobs, and these have been renamed twice already. Don't ask what they were named before. Blobs work as follows. They are indirectly referenced in pay for blob transactions. So this is the TX, the blue that you see in the square. And Celestia squares are laid out as squares, hence why they're called squares. Or Celestia blocks are laid out as squares, Hence why you see the squares in the picture. Here we see two examples of blocks of varying sizes. The pay for blob transaction is in blue. The blob itself, which contains the data for the execution layer or the L2 or what have you, that's in yellow. And this blob is committed to in the transaction. In other words, there's a Merkleized commitment to this blob. And this indirection, as opposed to directly including the blob in the transaction, which is what Ethereum does with its call data, this indirection allows you to have what we call partial nodes. In other words, they're nodes that can fully verify the Celestia state machine without having to fully download Celestia blocks. We have this new class of nodes that other traditional monolithic blockchains, or Ethereum specifically, if you want to say, don't have, because they don't have this level of indirection. It allows for pretty significant scale while having this very secure node type. That's good. Now, these blobs are committed to in transactions. They're also committed to in a Merkle tree, as is tradition. Block data is committed to in a Merkle tree. We have a Merkle tree, then you have other Merkle trees, and so on. There's various layers of commitment here. That was the background on the Celestia. Now let's talk about the bridge/stream part, and we'll fit these two together in a couple slides. So traditional bridges operate as a bidirectional asset bridge. So they move, for example, the Axelar bridge. I think maybe there was also an IBC bridge that was out recently. I forget. Can move funds between two chains, and they move funds specifically, or they can move messages that kind of create actions, either or, and it's bidirectional. These are traditionally how bridges have operated, and whenever someone says bridge, this is basically what people think of. There's pros and cons to this. The pros, of course, that you can move money around. The cons is that if the bridge is compromised, then this can result in very significant loss of funds, because the bridge contract or bridge applications are kind of the be-all, end-all. If they're compromised, then all the funds can be lost. And we've seen this in a variety of bridges, such as Wormhole and so on. How does Blobstream work? It's different in two primary ways to these bidirectional asset bridges, which is that it's unidirectional, and it does not bridge assets over. It only bridges data, or it only relays attestations of data being available. The zeros and ones here. So it will stream, kind of like how Netflix streaming is not you upload to Netflix and Netflix downloads to you. It's one directional, right? Netflix will stream data to you, and that's it. You see your movie, and that's it. So Blobstream will stream data from Celestia to Ethereum, not the other way around, and not assets. This has a number of benefits. One is that actually, I'll talk about this security benefit after I explain how layer 2s would integrate Blobstream. So how do you use Blobstream if you're a layer 2? Such as most recently Arbitrum Orbit, I believe, just a few minutes ago, got tweeted out that Arbitrum Orbit there's an integration with Celestia for data availability. So we'd have some system like this, a layer 2. It has to post its transaction data somewhere. In the traditional roll-up scheme mechanism, it posts its transaction data directly to Ethereum as call data. Very expensive, just absolutely very expensive. And more importantly, it has a low capacity. So it's expensive now, but as the rollups get used more and more, it'll get even more expensive because this data has to compete with everything else. To give you an idea on orders of magnitude, if Ethereum today has approximately dial-up levels of bandwidth, Celestia, with its default block parameters, block size parameters, is approximately like a broadband order of magnitude. So we're looking from going from dial-up to broadband. That's the order of magnitude capacity increase that we're looking at by using a system such as Blobstream or just Celestia in general for data availability. So this opens up, the door for things that just straight up aren't possible in Ethereum today. So you have L2, it posts the transaction data somewhere. In this case, if it's Blobstream L2, it'll post this transaction data to Celestia. The Celestia validators will Merkleize and batch together a bunch of Celestia blocks into a single Merkle root, and then relay this attestation on this batch to the Blobstream DA contract, right? This will verify the attestation. And then downstream L2 settlement contracts. So these are, if you're Arbitrum, for instance, it's the contract that verifies data availability and that adjudicates a fraud proof. If you're a ZK rollup, it's the one that verifies the proof and also checks that the data is available. Those kind of contracts those downstream contracts can then verify the attestation from the Blobstream DA contract, with very little change to their current logic, honestly. So what is the nice thing about this? The nice thing is that this relay contract, this relaying of attestations, is not actually the be-all end-all of security. What is the be-all end-all of security is still the layer 2 settlement contract. So even if there's some sort of compromise in the Blobstream contract or in the Blobstream relay mechanism, the only thing that does, it does not steal funds. The only thing that it can do two things. One, it can stop relaying data, which is, okay, it's a temporary liveness failure that can be recovered from. The other thing that can happen is that an invalid Merkle route can be relayed over. But as long as the L2 contract is honest, and as long as those sequencers are honest, then it doesn't really matter if the attestation is incorrect, because that attestation will just be rejected by the sequencers. So it's not a weakest link thing between the Blobstream DA contract and the L2 settlement contract. It's the L2 settlement contract is still the be-all end-all of security in this game. And this is different than bidirectional bridge, where the bridge contract is the thing that provides all the security. Okay, so what are some of the benefits now of Blobstream versus data availability committees and restaking type schemes? This is so other than posting data to Ethereum, various L2/sidechain projects have suggested doing a variety of things for data availability. One of them is using data availability committees. So these are a trusted small set of large ecosystem participants or whatever, does effectively leverage the reputation to say, we won't do anything bad, please trust us. And then this committee will sign over some data being available, or some data even being valid, actually, why not? There's also restaking. Restaking involves taking the Ethereum validator, restaking on Ethereum involves taking the Ethereum validator set and allowing that set of validators to also attest to other things, such as this data is available or this data is correct. Now, what are the downsides of data availability committees and also restaking, which are very close to each other in terms of the security guarantees they provide, despite the fact that restaking is much more complex? They're actually very close to data availability committees. What are the downsides? It's that if you do something that's purely reputation-based, well, you don't have any security, right? It's purely reputation-based. So we're back to the traditional financial system. If you have some mechanism to penalize the committee or the restakers, in other words, slashing, you have to ask yourself, who does the slashing? And this brings us back to what Nick was saying, who watches the watchers? And there's a few ways you can do this. But the most common way that's suggested is token-weighted governance, on-chain governance. But of course, there's the issue, and exactly as Nick said, it's not the validators that you want to control the chain or the protocol. It has to be the users, the developers, the developers of the protocol and developers of applications on top of it, and also token holders to a certain extent. Right? It's the entire community that you want to have governance over the chain/protocol, not just the token holders, and not just a subset of those token holders, the validators / people who would vote on governance. If that's the case, then, as Nick was saying in his talk, it degenerates to what we have in the traditional financial system very much. So if the only way you have to slash people is token voting, then that does not provide crypto economic security. right? Because the token voters could just decide not to. There's no penalty for them not to slash. Now, there is another way to slash, and that is with fraud proofs, for example, right? You might say, well, I mean, Optimism and Arbitrum have fraud proofs, and they have this thing called slashing. Why can't you just do that? So the reason that you can do slashing with fraud proofs is that fraud proofs are over an objective thing. You objectively, and you can also guarantee the availability of that objective thing based on your fraud proof scheme. Then you can slash people based on an objective fault that they have committed. Data withholding in a data availability context, as we've known for many years, is subjective. It's a non-attributable. It's not attributable to a single entity. And in such a case, you cannot objectively say that data is being withheld, and therefore you cannot objectively have a fraud proof that can be slashed. You must rely on either token governance, which, as we just said, is not ideal, or you can rely on off-chain slashing. Now, data availability committees and restaking do not allow for off-chain slashing. Layer 1s do allow for off-chain slashing, such as Ethereum, right? Ethereum's native proof-of-stake protocol, and the reason that it provides crypto economic security, and the reason that people trust Ethereum is not just because they trust the validators. It's because they trust the governance of the Ethereum community will keep the validators in check and will slash them if the majority of validators are dishonest. That's where Ethereum really derives the security from. Similarly, if you have another layer 1, such as Celestia, the community can keep the Celestia validators in check, even if a majority of them are dishonest. So in other words, to do slashing, to provide this crypto economic security, you really need it to be something that happens off-chain. It cannot be token-weighted governance. And this is where Blobstream is different and strictly better than data availability committees and restaking. It's because, since Celestia is a layer 1, the community can slash the validators if they misbehave in ways that the other two aforementioned things cannot. Okay, so we're wrapping up on time. If you'd like to find out more, there's an introductory blog post that was published a few days ago that reintroduces Blobstream under this new name, and that provides additional context, and that goes over a lot of what I discussed here. We also have validator docs. So if you want to run a Celestia validator and also want to attest to this data being available, that's the second link. There's also developer docs. So if you're building an L2 that settles on Ethereum, right, something like a rollup. Oh, sorry for that. There's a car passing by. Something like a rollup that settles on Ethereum and that would like to leverage Celestia for data availability. That's a third link. And finally, if you'd like to look at our smart contracts directly, the Blobstream DA verifier contracts, that's the fourth link on GitHub. So with that, thank you for listening, and I hope you check out Blobstream when you get the chance.
Awesome. Thanks, John. This was a really concise, succinct summary on how to do this thing, and turns out that seems like at least for me, the takeaway was that you kind of get to leverage the larger block space here, and not worry about kind of just throwing cold data and compromising on just abusing the L1 storage here. So this is awesome to see, and hopefully we all get to kind of see this in the wild and try it out.
Yeah, awesome. Thanks for having me.
Thank you. All right, well, up next, I want to bring on Jacob from the ETHGlobal team to take over as the MC for the remainder of the summit. So without further ado, let's welcome Jacob. Hi.
Awesome. Thanks, Kartik. All right. Cool. Well, really excited to be here with you all, and a big shout out to the last three speakers, all from Celestia Labs, and of course Celestia for helping put together the summit for us. For the next two talks, we've already heard about from the Celestia Labs team, open problems, stuff they're trying to solve, like clients, all this kind of interesting kind of open research problems that they've been working on with the team there. But now we're going to kind of transition to a little bit more about application. What does it look like right now to apply these technologies, and what's the current kind of state of building these modular blockchains? So really excited to welcome Prabal up onto the stage from the Avail team. So without further ado, bring him on stage, and looking forward to hear more about how you guys have built Avail and kind of different use cases you have for the technology you guys are building. So welcome to the stage.
Thanks, Jacob. Thanks for inviting me. And yeah, let's talk about Avail and how it the architecture looks like and what are the kind of use cases that it enables. So just before we go into the agenda about what are the things that we will be covering, I'm Prabal. I am a co-founder along with Anurag. Anurag was previously a co-founder of Polygon. Earlier this year, we took Avail out of Polygon as a spin-off, and to create a separate entity, we want to create a credibly neutral base layer for roll-up chains. And in this talk, we will mainly cover, how blockchains are changing. What is it that we are building? How does it look like? How are we trying to solve the problem of data availability? What the base layer constitutes of? How does the light client network look like? And then what all of this means? What does it enable? What are the kind of use cases that it enables? Where are we are in terms of development and the timelines, and the future optimizations in terms of how we can improve and so on and so forth. So yeah, I think till now you guys have already heard a lot about how in typical the rollups are like taking the center stage, and we have already recognized them being the main way to scale computation. And what a rollup is basically it acts as a validating bridge, which primarily allows people to do off-chain execution with Ethereum assets. Right? So that's how the rollups in the Ethereum ecosystem are kind of scaling the Ethereum computation. In terms of blockchain constructions, we are inherently seeing more and more modular constructions where people are taking a single piece of this entire stack and optimizing them and making them more efficient in ways and means in which they can speak to each other, communicate with one another, and be more efficient at the particular problem they're trying to solve. And one of the main caveats of this entire construction is that they are only talk about who will scale the computation and how the execution scaling works. But there is another problem which needs to be solved in tandem, which is how will the data scale? And that is where we come in. And the rollups are hungry for data availability, and we are trying to design a base layer which is optimized to solving that exact problem. The main key takeaway that we have is that every base layer blockchain is eventually going to be a DA layer. We are seeing Celestia, thanks to them for hosting the summit, and they are creating an L1 which is focused on DA. We are also seeing newer EIPs coming in, where Ethereum is trying to transition from being an execution focused chain to being more DA focused chain. And this trend is only going to be more and more as people try to bring more applications to the blockchain space. So what is Avail and how does it come in and fit into this picture? So Avail is a base layer. It provides one simple thing, which is raw block space for the rollup chains to use. It makes sure that the particular data that is submitted, that they are sequenced and packaged into blocks and published. Now, what this means is that it only makes the data available for a short period of time, so that validity proofs or fraud proofs for the execution can be verified and be usable for later. And how it works is that it segregates the transactional data on a per app basis, so that multiple rollups can publish all of them at the same time. But each of these individual applications can query only their own part of the data. Now, how Avail is bootstrapped and secured is that it will have a robust validator set that will sign off published blocks, but they do not do any execution in terms of interpretation of the data that is submitted to them. So it is very dumb in that sense. It takes only the blobs and just makes it available. And each rollup, which is built on top of Avail, has to interpret its own transactions. And they can be completely custom. We will talk about app-specific rollups and such. But just to give you an overall picture, it can be anything from EVM to being no VM at all, which is extremely custom and very circuit specific. But how does Avail work? Is that the light clients, they leverage KZG polynomial commitments, erasure coding, and DAS to allow the verification by downloading a very small sample of the data, but not having to download the entire data by itself. And what this means is that they can download all transactions for a single application rollup, and they enable the application full nodes, but they do not have to download other application data anymore. So there can be only light clients which download only a small chunk which by random sampling, but there can be application full nodes which download only the application specific data and not have to download other application data. But what does it mean? Is that it means that a vibrant ecosystem can be built on top. Different types of rollups can sit on top of Avail. They can be adapted for their own unique needs. Anything like Validiums and L3 ecosystems can be built on top. You can have many types of bridges. I think there has been recently many talks about what is it, does it mean for one thing to be a rollup, to be called a rollup. It can mean many things depending on where you're coming from, based on interpretations and such, definitions of how you define security, how you define liveness and things like that. But no matter how you think about a rollup, it can, all of this can come together and work on top of Avail. And what this also means is that state validating bridges, the strongest type of interoperability right now available, that is also possible, and this allows for asynchronous composability across the rollups which work on top of Avail. And because of this, because you all use the same DA layer, they can have shared security. So applications which are building on top do not need their own validator set. You are already seeing like rollup as a service, this kind of infrastructures where you just do one-click deployments of newer chains. This is all possible because they don't have to think about how to bootstrap their own security, as the base layer takes care of the security. And in the base layer, how does it all work? So essentially, it's very simple. It's almost like every other blockchain, how it works, but with a twist about how exactly the block construction looks like. So when the original data comes, they are packaged into a block, but instead of sending it as it is, it's actually erasure coded, and then a commitment of the data is pushed into the header. The header, along with the block, the entire block gets sent to all the validators who sign it off, and then they reach consensus on this particular block to ensure that it is present with all the validators and the full nodes. But this is not where it ends, because this would have meant that this is just another blockchain with no scalability benefits. So we will have light clients which do the sampling, but I will come to that. In general, for the block production itself, the applications send all the data blobs to Avail using a particular application ID. These blobs are chunked together and a particular 2D matrix is populated. They are segmented according to this app ID. The row-wise commitments are generated. Erasure coding is performed on the commitments, and the homomorphic property of KZG, it ensures that commitment of the erasure coded data is the same as the erasure coding of the commitment itself. The matrix is adjusted according to demand. So when the demand is low, the cost is low, the block sizes are low, and so on and so forth. But the demand is high, it kind of grows up to a particular point. The header, it contains only the commitments, the app index, and the sizes of the matrix. So this is what I was trying to mention, is that we have the data, it's broken up into this 2D matrix. They are extended column-wise to make sure that there is extended data and enough redundancy. We go ahead and commit to each of these rows to create these commitments. But the nice thing about KZG is that if you only have this particular side of the matrix, you can just produce the commitments and extend the commitments, and you do not have to extend each of these columns individually. And how does the base layer stack look like? We have built the main blockchain using Substrate, which is highly performant. And in this consensus, we use Grandpa and Babe together. So essentially, in consensus systems, there is this availability finality dilemma, which means that you cannot be highly available and still have instant finality. So just to kind of address that situation, we have Babe, which is the block production engine, which has been optimized for liveness. We have Grandpa, which is the finality gadget. And the leader election is based on a verifiable random function. And the finality is not reached on blocks, but on chains, which means that even if the finality halts for a particular amount of time, when enough people come back up, when more than 2 by 3 is available to finalize blocks, they can actually finalize an entire chain and not have to do it block by block. And what this essentially means is that it is tolerant against temporary network partitions and a large number of nodes crashing. What this also means is that we have nominated proof of stake, which is a little bit different from delegated proof of stake, where we see that when people come with large stakes, they inherently get larger powers. This means that they get larger rewards, and that leads to stake concentration, which essentially means that even though we have a very powerful base layer, it essentially turns out to be very lopsided in terms of power accumulation. And to avoid that, we have something like fragment election, which has proportional justified representation in terms of nominators, and nominators can choose not a single validator, but have a ranked choice of validators. This allows for high decentralization factor due to fair distribution of rewards, and that allows us to have around 1,000 validators in the active set who participate in finality of the chain. Now, coming to the light client network, the light client network, what it does is that we can have potentially millions of light clients. The light clients will all do very small amount of work individually, but collectively they will have sampled the entire block and much more with redundancy. So even if a validator goes rogue and tries to withhold data, the light client network has a peer-to-peer network of its own, which means that the replica of a block always remains available there, and it can be reconstructed from the peer-to-peer. So we have built the light client from scratch. We're built in Rust. It forms an overlay peer-to-peer network. It samples and uses the full node only for initial bootstrapping. But on the back end, like it uses a CatMDA-based DHT, which contains cell-level proofs, so anyone can verify the correctness of the samples. And when we scale up with more and more light clients, more and more data can be digested as part of Avail blocks. And there is no need to trust the validator set for the availability of the data. The light clients can perform data availability sampling and verify availability, even if the super majority of the validators of Avail wants to suppress the data. And that is a powerful construct, right? Because that means that once enough light clients have sampled, the data remains available, and there is no need to rely on a centralized RPC providers for getting any guarantees when you are using Avail. And that's a stark difference from how you use traditional blockchains today. And not only that, what we are doing is we are adding DA support to wallets where they verify both execution correctness and data availability guarantees to make sure that you do not have to rely on cryptoeconomic guarantees for the correctness of the data or the data availability. You only have to rely on them for ordering. In terms of performance, this is a bit dated. Last week or 10 days back, we released an improvement where commitment times have been improved by around 70%. So this has been reduced much further. Currently, we have the 2 MB block size with a few tens of milliseconds for building commitments. But we have tested up to 128 MB and beyond, and it works. So KZG and so on is not going to be the bottleneck. The bottleneck is coming down to block propagation and such. So that's what we are trying to look at right now. In terms of what it enables is that it enables sovereign rollups, validiums, optimistic chains, and so on. I will talk about them in a minute. But what it also enables is that you can have custom execution and custom state. which means that you can deploy applications which are very, very close to what you just need for your application. But on the other hand, you can also opt for Ethereum virtual machine or Solana or anything of that sort, any standard virtual machine you can implement. And we also have support for, let's say, Linux or some of the other execution environments as well. In terms of validiums and optimistic chains, there is a data attestation bridge which is live on testnet. What it does is that it takes the attestations from Avail and pushes it to Sepolia network for now, but you can basically plug it into any settlement layer, and then you can run a validium on top, where the validium kind of just sends the proofs or the fraud proof or a lack thereof to Ethereum, and all the data availability guarantees are provided by Avail through the attestation bridge to Ethereum or other networks. And that's how you can not only build like L2 validiums on top of Ethereum, but you can also have L3 validiums on top of L2 chains. This also provides the basis for sovereign rollups. What that means is that today you will see that most rollups rely on a settlement layer for validating execution proofs, but they can also be doing very well on a light client. And the L1 way of doing things is hard to upgrade, or you have to have a multisig and things like that. Social consensus is probably not possible because you would need an L1 to fork it and so on. But for sovereign rollups that do verification directly on application like clients, they don't have to rely on a smart contract. They can upgrade by upgrading their clients, just like you upgrade an L1. And the light clients can verify not only data availability, but execution proofs without downloading all the transactional data. And many different designs which are possible in this space: optimistic, ZK, with a sequencer, with a shared sequencer, without a sequencer, all kinds of things are all possible in this domain. In terms of where we stand, we right now are closing up our long-running testnet, which is a Kate testnet, where we have tested around 105 top external validators. And we have pushed huge performance improvements, as I said, a week or so back. Next month, we are going to launch our incentivized testnet, so I would welcome everyone to kind of come and participate in that. And hopefully early next year, we will have our mainnet, which is our target. In terms of future optimizations, where we can improve and so on, right now the validators can verify commitments, but every validator has to verify all the commitments from the block producer because they have to regenerate commitments. But we are trying to look at improvements where that is not the case. We are also we already have a PR, but we are trying to test and include the multi-proof KZG commitment so that, we can generate not only cell level, but particular submetrics level openings, which will mean that there are huge improvements in terms of how the DHT is populated, how the network streams work, how the bottlenecks of the peer-to-peer are coming into effect. But this will all be backward compatible, so existing LC interfaces will remain the same. We are doing changes to the LC interface as well, so we would welcome you guys to kind of come in and give us more feedback. In terms of the attestation bridge, we are trying to, right now it's optimistic design, but we are trying to make it a ZK snark based. The initial prototype is ready. We have already deployed it on Goldly. We are trying to polish it off along with Succinct, and we will make sure that it works even with a very large validator set, like 1,000 validators. Yeah, that's all from me. But if you guys have questions, feel free to visit our website, the docs, the blog. And yeah, we are also hiring. So yeah, thanks.
Awesome. Thanks so much, Prabal. Appreciate you taking the time to chat with us and share what Avail's working on. And congrats on all the progress so far. I mean, it's very exciting. And like you mentioned, for everybody watching, you should participate next month in that incentivized testnet as we kind of go to mainnet on Avail. I guess just had a quick question for you. Going through Avail and the design and and architecture strategy you guys have built, it really allows for like highly customizable blockchains on the other side. I was kind of curious, like, what your thoughts are about that trade-off between building infrastructure that kind of produces blockchain out of in a box type thing, where you could sort of be very strongly opinionated about how your tech is used, versus kind of open up that customization. Just kind of any thoughts you had on the trade-off between opinion versus open-ended.
Yeah, I think it all comes down to the maturity and the stage and the optimization and the application trade-offs that you're making. For example, if I am trying to run, I will try to deploy a website of my own, then I would probably take something out of the stack, deploy it, and then be ready that it works. Will it be most performant? Maybe not, because my needs might be very custom. But am I willing to spend too much time on it? If yes, then great. Then I would go through the grind to kind of making it more customized, making sure that I squeeze every ounce of it. But if not, if I just want to have something off the stack, then I will just use something like say DigitalOcean, right? And here also we will see the same, is that if you want to use the existing tooling, if you want to use all the existing benefits, a very good developer base, everything well known, then you would use something like say the EVM stack, and you would reap the benefits of it. But if you want to be, you have like custom state, custom transaction structure, you would want to design your own rollups, and we are seeing kind of both ways right now.
Awesome. Okay, well, thanks so much again for your presentation and for being a part of this. And awesome, we're gonna move on to our next and final chat. Okay, great. Thank you again to Prabal, and excited to chat with Senkit about the Polygon CDK, the chain development kit that they've been working on as well at Polygon. So awesome. Whenever you're ready, Senkit, I'll have you take over here. Welcome to the stage, and love to hear more about the work that's going on with the chain development kit.
Thank you so much, Jacob, and thank you so much for organizing this. And yeah, I think I'll probably just go dive into the. So recently, I think Polygon is kind of created like a chain development kit. The idea for us is essentially, as we started more as a side chain, then pivoted like through few parts and essentially reached here. The idea is right now there are a lot of things that are moving right now in terms of the way this chains and the infrastructure is being built and what's happening right now. So let's kind of lay the land here. Is essentially you have a lot of layer 2 chains and stack, which essentially ends up fragmenting a lot of liquidity across your chains in the Ethereum ecosystem, and it kind of even trickles down to the others also. There are a few where the security is not as what people promise. You end up fragmenting the whole block space, because a big part of like being a layer 2 or building some of this is you want to have at least a unified block space. And essentially then there are multiple topologies that people end up using, which ends up confusing people because not everyone is kind of, let's say, technical. And like in Web3, I think we will love to make names. We have made up so many interesting names, but we don't spend enough time to explain some of this. So eventually it ends up hurting the adoption. And I think essentially what we are trying to do, and when we created this Polygon chain development kit, the idea is we can stick to something which is which is kind of more longer term, which is more modular, and gives you the flexibility to kind of ensure that this is the name that stays, because we are also one of the culprits here in terms of naming stuff like in the past, with so many things kind of moving, and that's part of how the ecosystem has evolved. So this is kind of where the ecosystem is, and I think this is what we have been trying to build. It's essentially it is a chain development kit which is sort of a modular stack. Think of it as your Lego pieces of components for all the infrastructure for you to build your own layer 2 chains. And what does this mean? Just to break it down, it means you can create your own ZK based L2. So your security comes from the validity proofs that are there. You get your own dedicated space. You get to choose your own configuration. think of is like, you are kind of entering, let's say, a cloud architecture, like, AWS or a GCP kind of a thing, where you get to customize what sort of stack and architecture that you will have. And that's kind of the intent. So be it from a staking perspective, what's the staking token you want, what's the cash token you want, what is the type of bridge you want, what are the clients, what virtual machine, what even data will layer in that sense. Because I think a big part of this cost is also kind of depending on what the trade-off is you want, you kind of choose that. And I think from our perspective, the whole idea is we want to bootstrap the liquidity between, let's say, Polygon and ETH. And I think this is one of the major things why we have kept it modular enough where people can benefit from each other. So as I mentioned earlier, more from the fragmentation part of things, you can have a more unified liquidity. And I think right now, largely between ETH and EVM is where I think 80 to 90% of on-chain liquidity is kind of present. So I think that's one of the biggest reasons where you would want to start from. At the same time, build like the fragmentation doesn't get solved by itself. A big part of here, and this is where I think our expertise from our team in the ZK and the prover and things that we are building comes in. So creating a sort of a safe interoperability layer, which I'll touch base upon in the next slide. And at the same time, you have the ability to customize your stack and chain. So that's very simply chain development kit. Think of it as a customized way to create your own ZKL2s and kind of own your block space. Now, how does some of this thing work? Although I mentioned like, the interoperability, the fragmentation that we are trying to solve, it works essentially by this. Imagine like, I think probably for people who are watching would be good to focus on the diagram. Imagine there are a bunch of chains. Right now, I think we have at least 20 that we have announced. So Immutable, A-Star, Canto, and that is something that we'll cover up. But these are all different chains you build using this stack. Individually, they have sovereignty. So that means they are on their own and they are kind of their own chain. They have their own ecosystem. But collectively, from a block space perspective, from a liquidity perspective, we are trying to aggregate this using a ZK proof. And this is where the aggregation layer kind of comes in. And without delving too much into detail, a very simple idea here is each of this, that's why a ZK based L2, which proves validity proof onto this layer. And eventually we generate a recursive ZK proof that eventually settles on Ethereum. So all the chains eventually get security from Ethereum. At the same time, they have a very safe interoperability and a cross-chain finality between them. So there is a free fund of assets across this ecosystem. So what this enables us to do is move assets and messages, any arbitrary messages between the chains very easily. And that's how you achieve the interoperability layer. And the other kind of second order effect of this is this cross-chain finality that ends up happening at the aggregation layer, because each of these chains are generating their own ZK proof and validity proof once the state transitions happen. Just by kind of by allowing or checking the validity of it, you can essentially have a cross-chain finality. So your two chains can talk to each other, and it opens up a space where it feels almost near like the same sort of block space. Although it's obviously sovereignty, so you get the best of both worlds, where the asset movement is very easy. It's very easy to get the liquidity on chain. At the same time, you can talk to each different chain by at the same time having your sovereignty. And yeah, I think this is the larger, I would say, the architecture that kind of defines as well. The idea is you onboard, and I think this is where I think this probably would make more sense. Here, this doesn't only stop at your own layer 2. This also includes your existing public chains, which includes even Polygon POS and Polygon ZKVM. That is one of the two of our public chain. And at the same time, you can have as many chains that you want. So you are basically scaling horizontally, at the same time allowing people to kind of get access to the liquidity. So from the perspective of the chains, you are able to bootstrap on day one, which is kind of very important, because a lot of on-chain, like there are a lot of layer 1s and layer 2s and things that have been created, but they're not able to bootstrap, let's say, liquidity. And I think a big part of why a chain dies is there's not enough on-chain activity. And I think that's the fundamental problem, like, this sort of architecture kind of helps. So now, putting this all together, right, what does this essentially mean? And I think the way I kind of define, I think the way we think about it is, right, is essentially right now you want people to be using more stuff on chain, and then there are multiple problems, including like user experience problem, not having enough dApps, not having enough use cases, and bunch of stuff. But I think the most important thing right now is a big part of what makes like on chain is like you need to have liquidity on chain. And I think from that perspective, we kind of think of like chains as kind of the new tokens, where imagine like 2015, and there were like it was like just when Ethereum had started and few things were just moving around. It was very tough from a technical, like, to deploy even an ERC20, ERC721, or an NFT, until let's say few things kind of evolved. And I think right now that is what we are seeing from a chain perspective, where there were a lot of projects, including us, that have started like 4 or 5 years ago, but it was very tough to build your own blockchain. And if you start thinking from that perspective, it shouldn't be that tough. So I think from that perspective, how easy it is to deploy a token at this point, be it a NFT or an ERC20, it should be as easy to deploy your new chains, and kind of get the sort of customization. Because the reality is, be it like, let's say, whatever you're trying to build, you need like a certain way where you can customize your own stack, that helps you create things the way you want, that helps you give the best user experience for your user. At the same time, you are kind of part of this larger unified ecosystem, where you are able to get a lot of network effect from the ecosystem that you are in. Right now, I think it's a very fragmented ecosystem, and it becomes very tough for people to kind of build on top of it. So I think this is what eventually is what is happening, and this is part of our roadmap with Polygon 2.0. For the next 2 to 3 years, you will see a lot of these things kind of getting built slowly, starting with Polygon CDK. And I think this is where it all starts for us. So yeah, you can have all the network effects of the good work that has happened so far in the Ethereum space, in the EVM space, and this goes even beyond EVM. This goes even like, that's where we have projects like Canto from the Cosmos ecosystem, or A Star from the Polkadot ecosystem, and few others that are kind of in pipeline right now. And then that's kind of the idea. Having said that, this also allows people to have that EVM equivalence for just maybe one or two things, which is, you want to ensure that you're able to get the developer network effects in the developer infra that has like been built for EVM, because it is probably one of the most mature ecosystem in terms of the amount of developer mindshare and power kind of goes into it. And we can argue along what are some of those performance metrics, but the reality is, this is where I think it's the most mature in terms of anyone wanting to build an on-chain thing. EVM developer toolset is probably the best right now, and I think that's kind of what essentially you get when you build with some of the stuff. At the same time, you can customize your DLA, and I think this is one of the things where right now, because of the way layer twos are kind of the rage, and like people have been talking about it, the DA layer and like the good work that Celestia and like few others have kind of done in the space is create a good education around it. And I think right now people want that flexibility of the DA layer by themselves, so that they publish the data to a chain, and at the same time ensure like there are certain security trade-offs are also ensured with that. uh, this is the other thing for us is essentially obviously the security, because when you are building some of these moving pieces and components, you want to ensure that security is absolutely there. I think firstly, that's where I think being a layer 2 definitely helps, because a big part of your security is inherited from Ethereum. And I mean like actually Ethereum, where to some extent having Ethereum as a DA layer is also important. And I think that's where some of the final finality kind of comes in. At the same time, lot of this code base that is being done uh, is being done by us, and has been multiple and audited by multiple folks from the community, as well as like from your trusted auditors that are there. There are multiple audits that are done, and I think that's why we take the security very important in that sense. At the same time, we are doing all this from an open source, so the whole goal is the community kind of gets involved, and it kind of helps and like self-regulate some of the stuff, because the best way to build out is in open and doing it open source. So I think this is kind of our way, because a lot of things in Web3 and crypto has been built which is open source, and I think we intend to keep it that way. And I think that's where a lot of our prover designs and a lot of the the L2 stack itself, or the new VM with Maiden that we are building, it's all kind of being built open source. In fact, with few of these things, we are actually discussing right now directly to discuss it with the community directly on the dev Discord that we have. So with Polygon Maiden, that's kind of what's happening. So I think our goal is to kind of combine people, so you have like a collective way where all of us are solving problem together, and at least that's kind of the intent. And at the same time, I think from our perspective, a lot of this thing is enabled mainly because of ZK. So Polygon 2.0 is basically going all in with ZK essentially, because of the security that it provides, because of the way it provides the scalability that you need, and at the same time allows you to have that flexibility to kind of build your own stack the way you want. And although I keep seeing like Ethereum and L2s and things, I think just to put in perspective, this is not just for that. I think it is not only for the layer 2 builders. That's why I think if you see the kind of people that are building right now, it's Canto who has built like a custom sort of Cosmos and Evmos sort of a chain. With the same time, A Star, which is more of from a Polkadot ecosystem, they're all sort of building their own sort of version and connecting to the aggregation layer and building using the CDK stack. At the same time, I think right now there's a proposal live on Celo also, where I think we are exploring like using that prover. And I think that's the beauty of the CDK stack, which is it allows you to customize stuff. So for example, with Celo, I think there are a few things that they have already done from an architectural perspective, but there's a scope of them for using a ZK prover, and we have a proposal live there. And I think that's the intent. The goal here is essentially be able to bootstrap your own chains when you create, have your own sovereignty, have the ability to move assets very easily, and that's where the interoperability comes in a big part. So you get the customizability, sovereignty, and the liquidity that you need for you to do so. So as an app, or as someone who's building a project on this, you don't have to worry about the infra, because like not everyone needs to build this thing, and that's kind of where we are hopefully combining together. These are some of the ones that are there live, and it's a bunch of different folks. So Immutable is from one of our like they're building a gaming CDK chain with us, and have onboarded almost 100 150 games already with that. IDEX is one of those OG sort of perpetual protocols, and then they are kind of creating a IDEX CDK chain just specifically for perps. Gnosis Pay is one of the best ones that I personally also love, because of the fact that they're building a consumer pay, building like almost like a self-custodial banking, using like their safe and like the Gnosis Pay thing. So they're building a Gnosis Pay CDK stack with us. Nexon is one of the largest AAA gaming studios in gaming. They're building a lot of their games on top of the stack. And at the same time, Nubank, Capex, Palm Network, which is very, very well known for like some of the NFT stuff that they've done. And there are many more. These are just a few of them. So I don't want to be disrespectful for others also, but this is what we could fit in the slide. So that's it. But since then, more than I think 20 plus projects have publicly announced, and there are almost 50 to 70 that are in pipeline that we will see more and hear more about soon. Yeah, and I think the intent is let's make something together, and that's kind of the vibe that we want to probably live with and build with open source community.
Awesome. Thank you, Sanket, for your presentation, and awesome for all your hard work on Polygon CDK. And great to see, mainstream adoption by some of these like largest either gaming or NFT or even payment protocols. So great to see that as well. Just one question from my end. We were just had Avail on stage, and they sort of were very focused on really making it up to the end user on the blockchain side, what kind of blockchain there is. One of the main differences I think between CDK is that you have a very strong opinion about the resulting blockchains being ZK focused blockchains. We'd love to just maybe double down or hear a little bit more around like your decision making around those being focused on ZK rather than any of the other kind of validating schemes.
Yeah, I think okay. So I think two things. Firstly, because ZK proofs are like superior, like period, because you get like a deterministic finality. It's not an optimistic scenario. At the same time, the security guarantees of ZK are like just like very different. That's one thing. I think the second thing is the aspect of the ZK prover itself, because and that's why I think if you think about the modularity of what we are trying to do, right, is be it let's say your Ethereum ecosystem, Cosmos, Polkadot, or like some of those larger L1s, things still work, because it is the ZK prover that gives you some of these things. And I think a big part of what our roadmap is integrating with some of these other, custom environments, working with custom DA layers. But I think that's kind of the intent, where the idea is ZK prover is what is the key piece to this. And this is where I think our team has built Plonky 2, and we are in the process of launching Plonky 3, which is like an upgraded prover, so that anyone can kind of leverage it and like use this. But that's kind of the idea.
Got it. Very cool. Awesome. Well, thank you so much again for your time and for your presence here. And awesome. I think this basically wraps up our Data Availability Summit. So thanks again. And for everybody watching at home, really thrilled to have you join us here today for the Data Availability Summit. 5 great talks covering all of what the future of data availability looks like, modular blockchains, as well as sort of some of the present, like how you can use these technologies right now or soon. So thanks again to everybody for coming. And just as we wrap up, of course, this was part of ETHOnline. If you're a hacker, if you're excited to see how ETHOnline, this last month of hacking, wrapped up, just a note that winners are going to be announced this Friday. Same place, ETHGlobal.tv, come and watch. We'll see some of the finalists demo their projects, as well as go through all the different winners from all the different prizes from our partners. So if you're interested in seeing what people built, that's this Friday, October 27th. It's going to be right here at ETHOnline again at 12 p.m. Eastern. We'll see you there. Bye-bye.